Alright, is everyone here? Is everyone listening? This is part 2. I hope this I hope this piano is not too loud. Also, I need to turn my lights on in my room because it's very dark. I'll be right back. Alright, I am back. I have some chill piano music playing in the background. I hope that's not a big deal. I think it's gonna make this stream a little less stressful for everybody. Let's get right into it. I'm gonna go ahead and check out my YouTube stream real quick and make sure it's all going well. So before we start, I want to make sure that I'm putting out quality content and that this isn't like some very strange stream. Alright. So obviously, this is our Python Minecraft video. Alright, let's see if the stream's coming through. Seems to be coming through, cool. Okay guys, so this is part 2 of the Minecraft and Python video. So essentially, I'm gonna go ahead and do a recap because I had a very embarrassing first video in this series. So essentially, I have my folder here, Minecraft Python edition. What we have going on, we have a pre-made Minecraft that was made by somebody else, and if we run this, I'll show you all what's gonna happen. So let's see, I guess I need something to run it with. Edit with Notepad. Let's see. I wonder if we need to rename. I wonder if we need to reinstall modules. Let me see. It's just one thing after the next here. But let me check this out. Let's see. I believe, let's go to history. We were at a GitHub. Let's see. A while back in the gap. Alright. It was like somewhere around here. No, it was before that. Okay. I'm gonna show y'all. I want to give y'all a recap of what's up. So let's see. Alright. So let me put this into the command prompt real quick so I can show y'all what's up. Let's put the library. I want to show y'all what Minecraft could possibly look like at the end of this series. So obviously I need to reinstall some libraries because some are missing, which is not cool because we do not want to be missing libraries. Okay, so I'm going to show y'all what a possible Minecraft could look like, and we are still having errors. I'm going to go ahead and open it in a different, I don't know, we're having problems because Python is acting up in this particular reader. That's kind of where all of our problems are coming from. But let's go ahead and open back up what we already have. Let's see. Minecraft Pi Edition is what we're trying to create. Alright. So if we run this, alright, let's see. We're already getting problems. Let's try this. Already satisfied. Okay. So let's install OpenGL maybe. This should help. Okay. I'm guessing we should probably restart the process. So there's a process that we've been going through in this video so far to create Minecraft, and I think we need to restart. Let's get this started at a clean spot.
Tutorial video where we're
okay. So essentially, what we want to do first.
So if you open up Terminal, or if you're on a Windows machine, or
this is the tutorial I'm kind of going off of.
Maybe PowerShell or something like that, and then you're going to use pip install.
Okay.
Pip install Sina.
Pip.
First thing.
Oh, we're gonna wait on this.
Return.
Install.
And that will install.
Let's see.
If you have some problems, maybe we're using pip3.
I believe it was your Sina.
Sina.
Yeah.
And
Cool.
we're going to install.
We're installing the game engine that we're going to be creating Minecraft on in Python right now. We're redoing this compared to the first stream because on the first stream, since then I've reinstalled Python entirely and reinstalled the IDE for that. So I think we're good now. Let's try this. Let's try this again. It seems like we're having a lot of trouble with this at the moment, but we're making progress for sure. So let's see. We want to import some different libraries. We're getting a no module named Piglet problem, which I'm assuming means that, let's see, from Piglet import image. No, okay. Looks like, yeah, we don't have the proper thing installed. We don't have the proper library. So let's go ahead and fix that. Let's go to, oh, we don't want to do that. Okay, readme, how to run, install. Okay, I'm gonna try this one more time. Try to show y'all what I'm seeing here. Let's see. All right. So we already have all the requirements. I don't know what's up with this right now, but it's very strange. It doesn't want to run. Let's see. I'm gonna try it. No, it just doesn't work. I don't know. This was our Minecraft. This was somebody else. This is somebody else's Minecraft clone that they made on Python, and I was gonna try to show y'all again because I thought it was pretty impressive. But this is 1,000 lines of Python code coded by somebody that already did this project that I'm doing. But we want to do it ourselves because we want to be original. So obviously, his version of Minecraft had like 6 blocks in it instead of like however many Minecraft has. But in our version, I'm gonna go ahead and show y'all what our plan is so far, which I've already shown y'all on a previous live stream. I was gonna show y'all one more time so I can, and also I need to make this into a PNG because it's really annoying to open up every time. Essentially, our plan for Minecraft in Python Edition, we're gonna have a sine or cosine graph and use that for terrain generation. That's what our original plan was. However, the YouTube video that we're currently following, he uses this idea called Perlin noise, which this is what Perlin noise is. It's this like grainy looking stuff. If y'all can see what that is on here, this like grainy, cloudy looking stuff. It's like they call it noise, and this can help you generate terrain. Terrain. And that's more random than just a hill after hill after hill, like you get in cosine or sine, which is 2 functions on graphs that look like hills. So obviously in goal, having lakes, trees, we're talking about how blocks render in our how blocks would render in our Minecraft. We want to have 3 sides rendered at a time, not the back side. Well, let's see, there's a bottom side, there's a bottom side down here, a back side right here, and a back side right here. We don't want those. We just want this side, this side, this side. So we're trying to render the sides that the camera will see. This camera is only going to see the top of the world from this angle. We don't want to have the bottom of the world showing, not showing, but rendering and using up all that RAM. So some basic stuff we've been up to in the previous episode. So if I was to try to code this in Minecraft, step 1 would be to open up the Python IDE, which I can't remember exactly what that stands for, but that's what you call a program that allows you to edit Python files. So essentially, this will allow us to save all of our work into a .py file and allow us to execute that work and see how it turns out. So I'm gonna go back to the video that we've been watching, and essentially what I was trying to do a second ago, like I was saying, showing y'all another person's work of it to show y'all what's possible of. Here's somebody else's work in action. This guy has like a pickaxe that can break stuff. He's got some terrain around, which he'll show it. A creeper. So he's got some pretty good progress. He's obviously a very well experienced coder, and I was gonna kind of look at how he did it and work with that. So obviously, he's way more experienced than I am. Okay. So I'm restarting since last video. Last video we had a lot of problems.
And troubleshooting things go.
I'm gonna do my best to get caught up. I already know that from the beginning. From the beginning, we want to import from. I believe we put from. No. We want to from Ursina import star. Okay, I'm doing this for the first time. Maybe y'all can learn with me if y'all want to, but that's why I have to watch this YouTube tutorial, because I am very new to the Python world, so I have to learn the tips and tricks. Okay, so I remember last time from Ursina import, and then we want to create a window. It looks like he defines app first. App is equal to Ursina with the Ursina function. I'm not sure how we use that. I don't know what that function is. Window.color. So we're gonna create a window of the color, and last time he chose like an RGB string. I think, I don't know if that's what you call it or not, but he chose an RGB color. Yeah, I guess an RGB function. He wanted to get pink. I want to get red, so I'm gonna try to get a red function. So if we wanted to get the color red, obviously RGB, red, green, blue. I'm gonna give a full, like the maximum we can have is 255. I'm gonna give a full red, maybe like 25 blue and 100 green. I don't know why. I just feel like those would be cool numbers. So let's listen to see what he has to say.
I don't want to see the exit
He's very quiet.
button.
Okay, he doesn't want to see the exit button. I'm gonna follow him. I'm gonna copy him for a little while until we can kind of figure out what's going on, because we are, like I said, very new to this world. But if y'all want to follow along as well, feel free to follow along in your own Python console. But yeah, let's see how this goes.
We
Okay.
want our app to
App
run.
To run, yeah, we want our app
Let's
to
just do
run
that
so we
for
can
now. Let's
see
just
it.
see if I've got that right. So I need to save my Python.
All right, he's gonna run it. Let's see if we can run ours. Okay, so we have a problem here because our Python interpreters are not noticing our libraries that we have installed. So let's see what's up with that. I'm actually gonna go ahead and try to open it in idle. This really white bright program down here in the bottom is called idle. Let's see, desktop, Minecraft. All right. So this little white program is called idle. We're gonna try to run our Python script that we just typed up, and we're getting an error. No module named Ursina. So obviously Python is not being recognized by the system at the moment when we install these libraries. Let's see. Why is Python not recognizing my libraries? Okay, and the problem with this, Python is not recognizing my downloaded libraries, which we need to create Minecraft. So let's see what's up with that. There's only a few basic things you can do without having libraries installed in Minecraft. Let's see. I bet you the libraries are with the wrong Python, because I have two Pythons downloaded, I believe, at the moment. Let's see. I actually have the Microsoft Store version as well, but let's see. Alright. Python. Oh, it looks like they have every version on the store. That's kind of weird. I don't know which version I have. This is so confusing. I believe I downloaded 11 last time. Let's see. You can find these in your apps list. Cool. So the problem here is that I probably have Python 2 times, so it's probably very confused. Let's see, element of P. Okay, so we have Python 11 and Python 12. I bet you Python 12 has, well, and the weird thing, let's see, I don't know. I'm guessing that you can download idle separately, because I don't see idle from the, yeah, here we go. Here it is. Okay. I'm going to try to open the same file. Let's see. Desktop, Minecraft Python edition. Okay. So if we try to run this, it works. Okay. So the problem here is that we have 2 different Python versions, and only one of them is picking up on our required libraries. So what I'm going to go ahead and do is the Python that is working, we're going to want to keep track of that. So let's we need to figure out where this file is located at. Let's see. I'm going to go ahead and run it. Yeah, let's run it. And then once it's ran, we want to We want to open the file location, but it's being very strange. Let's see. All apps. Go on to Python. Okay. This is the problem with the Windows apps. You cannot see where they're located at. Obviously, with the Python that we downloaded ourselves, we can open up the file location. Let's see, programs. We need Python. We need the other Python to show up. I'm going to look up where is the Microsoft Store version of Python stored. Okay. Let's see. The common installation paths. Let's see. Start menu, select the search in the right menu, enter Python. Okay. You can find more to install it on Windows by, let's see, typing Python, right click on the app, open file location. Okay, we tried that. If we type in Python, it's not going to show us the location, which is kind of annoying. Okay, this is a pain in the butt. Let's see. Oh, I know what we can do. Let's open up idle. And idle is installed in the same directory as Python. So if we go to, let's see, open a module. Where are modules stored at? Enter the name of a Python module to search on sys.path and open. Let's see. We want to figure out what's going on with that. Path browser. Recent files. Okay, let's open. Alright. So this is where Python is downloaded at, I believe. No, this is Windows 32. Python might be in here, though. No, it doesn't seem so. I don't know. This is quite strange. Let's see. I need to find the download location of this. Let's see. Okay, this looks like a download location. We're gonna want to go to users, me. I don't know why there's two. That's kind of weird. Packages, Python. Let's see, app data. Okay, it gets very confusing at this point. App data, local packages, ABCDFG packages. Let's see, there should be a Python element OP. Okay, Python. Let's see. App data. Let's see, Python local cache, local packages, Python scripts. Okay, this is looking for a very specific file. We're gonna kind of raid this directory and try to find what we're looking for. Dang, they're just. I cannot find Python. We kind of have an idea of where to look though. Let's check. Maybe roaming, local low. No, it's not in here. Let's check roaming. Python 113, 311. Include pygame, include. Okay, that's not what we're looking for. Site packages. Man, I don't know what the heck, what is going on here, but let's oh, I know what to do. I actually saw this command earlier. It was you can type in where Python, and it'll tell me where it's at. So we've got one Python in our Microsoft Windows apps Python.exe. Okay, that's what we need. We need to find the location of this. Control C. Let's go to. Let's just go here. Control V. Okay. This is very strange. It's not showing it. Let's see. Maybe I have hidden. I don't know. Somehow, some way though, there is a Python app in here. Don't ask me why. So this is the location of the Windows Store Python app. I don't know why it's here, but it is. So we're gonna actually go ahead and let's see. This file has been modified by another program. Do you want to reload it? No. What I'm gonna go ahead and do. Let's see. I'm gonna change this up. Let's see. run. Let's go to plugins.
File, Pycraft tutorial 1. Let's run this.
Grammarly's top 3 tips on starting.
Okay. I kind of zoned out there for a second, so I was pretty quiet, but we have made some excellent progress.
An
Let's get
essay.
this out of the
Let's
way.
say you're struggling.
So I'm going to try to do my RGB window one more time because I want to practice RGB. I want to learn it. I want to learn how to choose colors based on that. So let's go 10 and then 100. I don't know what I'm doing. Don't ask me. Okay. So if I start this program up, I should have a specifically colored window. Okay. I made a pink window. I don't want a pink window. I want to have a red window. So let's see if this is red. I mean, obviously, yeah, it's red. It's like a cool shade of red. The exit button is here, which is different than his because he has a different exit button. But
Selecting exactly what
I think.
So I set that.
Let's see what happens to his.
And I think the
Okay.
Oh yeah, that's very pink. Oh, I've got my exit button. I shouldn't be able to see that.
Oh yeah.
Let's see if it's working.
He was
It is
talking about how he
working.
didn't want an exit button.
Let's just go to my already prepared code.
Okay.
Asina window color. Window exit button visible. Aha.
Window exit
That's
button
what I
dot
got.
visible.
So exit button.
Now if you run it,
visible is
we
false. And now
don't
we
have an
can
exit
see
button.
that.
Cool.
We're gonna have to change this pink. That was a little painful. Let's just mute it down a little bit. A nice tropical.
Yeah, it's a slow process.
Greeny, bluey turquoise.
Let's I wish this could be
And
louder.
we want a cube. So how do you make
Alright.
models and things
Playback speed.
in Asina? Let's just call him Jeff.
Okay, so currently we're learning how to make models inside of this. It's a Python game engine, but it's essentially Python code, just a library in Python. So what we're going to do now is we're going to create a cube, is what he's saying, on our tutorial that we're watching.
Is going to be our entity. So Unity.
It's gonna be our entity.
Unity. Asina uses entities.
Okay.
And that's how to create an entity. It's that simple. We've now got an entity called Jeff in our world. We probably won't be able to see him because he doesn't have a model. So if you want a cube,
Okay, so we've essentially just created a entity titled Jeff, and entities are like what these things are called in this game engine, which is your Cena. The entity, we're gonna make it a cube, I believe.
literally just like model equals and then in as like a string cube. There we go. Save and run.
Okay.
We've got our cube. It looks like a
So as you
square.
can see, he created a white cube. I believe this is what he typed. Let's try it. Okay, our cube did not work. Let's go back a little bit and see what he did. So he
Cube.
put model
Literally just
equals.
model equals and then in as like a string. Cube.
All right. So he put Jeff equals entity. All right, we did that too. Model equals cube. It looks like he didn't put a space here. That might be a difference we need to worry about. Yeah, we have a cube. Cool. I don't know what this cube can do yet, but this is step one. Hey.
There we go. Save and run.
All right. So we've got our little cube.
Yep. I can see. I need to be able to escape actually. So let's just write a little function.
All right. He's writing
Input. And it's going to take key. And we're just going to say if
def
key
input
is
key.
or escape.
All right. If key
Then escape. It just reminded me of.
I'm bad at touching the equal button, like really bad.
Or funny name.
If equal key is Q
escape, then we're just
or
going to quit.
escape,
I think you could also use exit. I'll use both of them. Why not? Oh, it's kind of going a different colour.
Alright.
I'll use quit.
we're gonna do
Let's just see
quit.
if that now works. And we'll get our cube. Let's give our cube
Okay.
a colour. Colour
He's giving his
equals
cubic color right now.
colour dot.
So yeah, I'm sorry that this
I'll say pink.
is such a weird stream, but until I learn how to
Run.
accurately code in Python, like quick enough and advanced enough, I'm gonna have to watch tutorials. I feel like. I mean, it'd be hard to do them without tutorials. But as we can see, we should have a green cube on the screen, and the screen should be red. Let's see if that's true. All right. Oops. Invalid syntax. I have some bad syntax. Looks like. Okay, yeah, I see what it is. I didn't put a colon here. That makes a big difference. All right. Oh, another invalid syntax. Let's see. I put dead instead of deaf. That's strange. All right. I didn't actually. We haven't started the input yet. We've defined the input. We haven't used it yet. Okay. And looks like we have a problem with green. That would make sense. Let's see what he does.
Want to set your designs free? Try Shaper 3D
Oh my
and
gosh, the
experience.
ads. Okay.
And we've got pink cube.
So essentially, what we're doing wrong is,
Colour. I'll just use quit.
let's
Let me
see.
see if that now works.
I'm gonna have to wait on this.
Colour dot.
Okay, so we didn't say that it was a color. We didn't define that it was a color. We're telling. So color equals cool. So now it should work. Essentially, we have a red screen with a green dot in the middle. It looks like Christmas, so we're doing good. Let's cool.
I'll say pink. Oh yes, and I just needed to increase the amount of blue. Save the file.
So yeah, in our RGB we have red, green, and blue. If we want it to be more blue, we'll increase the blue. If we want it to be more green, increase green, and then red.
Press Q.
So
Yes,
it's
now
pretty
it
cool.
quits. That's nice. Okay, how do we get our cube rotating? Well, notice that the Asina
Okay, he's trying to rotate the cube.
has an inbuilt input function and for dealing with input, which is really easy. It
That's pretty
also
cool that there's an
has,
input
like
function like
Unity,
that.
an inbuilt update function.
Alright, define,
Just ask
update.
Jeff to rotate. So I can say his rotation underscore
Jeff
one,
dot
that's the
rotation.
Asina convention for getting, say, the X
Underscore.
rotation, Y rotation, axis rotation, sorry.
Okay.
And I can just say plus equals, let's just say 0.1.
Alright.
And on every update cycle, Jeff should be rotating. Now, the one bug that might happen is that update might not know what Jeff is, so I might have to add him as a global variable.
Okay, so let's see. He was talking about update may not know what Jeff is. We may have to add him as a global variable. Which the good thing though is Jeff is already a global variable. We don't have him inside of a function, so I don't know why he'd have to be a global variable. But essentially, he should be slowly rotating along the y-axis. I don't know exactly how that's going to work. Let's try that out. Okay, cool. So it really is a cube. It's like 3D. You can't really tell that well, but he's slowly rotating in circles. This is a 3D green cube. But let's see what he does, because it's kind of, it's not very exciting yet.
Let's just see. Yeah. Oh no, it is actually working. There is some rotation happening.
That's pretty fun.
Let's add some more rotation, maybe texture. So let's add rotation to the x-axis as well. And let's just increase that by 7. That one by 3.
Okay, so now we're trying something else. We're going to rotate Jeff along the x-axis. Okay, rotation underscore x again, basically. Plus equals 0.7. We're going to increase the rotation speed. Let's test this out. Okay, we're going to kill the last one. Try it again. Okay, cool. So now I have a spinning cube that spins in 2 different directions. It spins along the y-axis, and it spins along the x-axis, and it spins faster along the x-axis than it does the y. So this is hard to visualize, but it's spinning. Cool. I'm not gonna worry too much about that.
And we need a texture so we can actually see things properly. So
Alright.
first I need to go and get a texture
So he's gonna add a texture. This is gonna be the cool part.
and put it in my in the same folder as where you saved your Python code.
Okay,
So that's the
we need
right
to get a texture.
thing. That's what I wanted to look at. I want to look at
Let's see, what kind of textures is he gonna get?
my folder. So this is my folder. I've just got my Python
Alright.
code in there. I've got some assets prepared.
Let's see.
So let's go to textures. And I've made these just using GIMP and some noise. So grass 14 I'll use. So
Alright, so he has like some grass textures. I guess let's look up like 8-bit grass. 8-bit grass. Maybe we could find a free like image. Let's see. We're going to texture our block, and of course, we may make it original soon enough. But at the moment, we're very, very basic. Let's start off with this simple grass texture. Save image as, and we're going to save it to. Y'all can see my thumbnail assets. Let's save it to here with our Python file. I'm actually going to name it something more simple because trying to type in that huge name is going to be a pain in the butt. Okay, let's close this as soon as we can. Okay. We do not want Microsoft Store open. Alright. Slowly but surely we're getting this figured out. So, we have our texture. Let's name it 8-bit grass. No, let's not put that dash. No, it should be fine. Grass. Okay.
Well, I'll go for grass 14. It's got like this white border, so we can see where cubes are. So let's just copy that. Go into my folder.
Alright.
So where my code is.
We're currently about to add texture to our cube.
If there's another folder, I'll just make one now, and I'll just call that assets. Even though they're now not in the same folder, as long as this folder is in the same place as where your code is,
okay.
The Asina engine will be able to find your textures and your other assets like models and sounds.
So now we're gonna go ahead and he's very smart in starting to get organized. We're gonna make a folder and call it textures. We want to have a textures folder to hold our assets in. We don't want to have them all spilling out all together. So let's go ahead and add in our texture.
Asina works really nicely for things like that. Right. So now that we've got a texture ready, I'm going to say texture is, and I'll call this grass text. Actually, grass stroke text, because it's got like a stroke or a line around it. So this texture doesn't exist yet. I could load it in here, or I could just put the name of the file here. So I could just put, what was it called?
Okay, so let's see what he's trying to say.
Stroke text, things like that. Right.
So
now that we've got a texture ready, I'm going to say texture is, and I'll call this grass text. Actually, grass stroke text, because it's got like a stroke or a line around it. So this texture doesn't exist yet. I could load it in
grass
here,
texture,
or I could just put the name of the file here. So I could just put what was it called? Grass 14 PNG.
Let me see what mine's
I could
called.
just write that there, like this. It's just grass 14 PNG. That will work.
Okay, so he is defining. He's defining texture, and I'm assuming that the indentation under. I'm assuming the fact that we're indenting under the model means that this texture will be like assumed part of this model, but it could be otherwise. Like it could be this is just general texture equals this, but it looks to me like we're going to assign a string to the texture variable, but we're probably going to be adding a texture to this model. Let's see, my grass is called 8-bit grass.jpg. Okay, 8-bit grass.jpg.
Let's just see if that works.
Oh, and he I see what he's doing. So he's extending the parentheses until after this texture. So if we run this, let's see what happens. It does take a second to run, surprisingly. But oh, perhaps I missed a comma. Let's see. I don't believe so. Maybe we put a space here we weren't supposed to. Okay, we're having trouble. Let's oh, we forgot a comma after. Okay. So when we extended this parentheses out onto the second line, we needed a comma after the first line. So that makes sense. Let's try it. All right. We have a rotating green grass block. That's already a big improvement since we first started the series. So episode 2 so far, we have a rotating grass block. Cool enough. Let's see. What are we going to do next?
Yeah, there we go.
Okay, his looks weird.
So,
I don't know why his was like pink.
I just pressed.
Okay, I see. His is pink. Mine is green. Mine's green like grass is supposed to be.
Clicked on the screen and it quits. Interesting. So
okay.
maybe before when I thought I hit the button, it wasn't just invisible and still working. Just anything that I was doing in terms of input quits the program.
All
Hopefully
right.
that won't be a problem when we start doing things. Yeah, I don't know why that's happening.
Okay, we're watching him at 2
Right,
times
let's,
speed.
Let's continue. So I was just showing you how to load in a texture, and
All right.
we want to put grass stroke text there because I want to load it really. You want to load your textures before you're using them, like during the game, because that might slow things down.
Okay.
So grass stroke text.
So he is essentially going to. I was right in the fact that we're using a string. We're assigning a string to texture, and texture is the word texture itself is understood by this game engine. It understands that Jeff has this texture. Yeah, and whenever I double click Jeff, all the Jeffs are highlighted. But Jeff is an entity that's a cube, and it's green, and its texture is this. And it understands what texture is. It understands what model, entity, color, green. It understands all these words. But this is a string that represents the location of this, or the name of this specific texture. So let's go ahead and what he did, he controlled exit. He cut it basically. He copied it off. So what we're gonna create a variable. I guess I'll just call it grass, because why not? With a capital G. And then up here, he goes under the input, and he's gonna define grass. So grass is equal to this string.
X equals.
So if we run it, we should still get
Texture.
a green cube. All right, it
Now
works.
we put in the same
Cool.
thing. Grass 14. I think I can just leave it as grass 14. Again, Asina will just go and find your file. I'll just put PNG.
Okay. Well, he did grass equals load texture. I don't know. Maybe. Okay. That essentially what I'm doing is I'm defining grass as a variable to define it as the 8-bit. I'm defining grass as that texture, and then whenever it gets to this point, it does the same thing essentially. It just loads it up at that point. What we want to do is we want to load it previously. So we're gonna be like, oh, let's load texture beforehand, because he's like, oh, it's gonna take a long time if you load it every time there's a new model. He's like, let's load all the textures prior to starting the program. So now it should still work, hopefully. All right, it does. This should be a little faster to load up the texture before we need
Maybe
it.
that's faster. But there we go. Save that. Good. Now we're gonna talk about the next thing. So, I guess what we want to do. If I just press a key, yeah. If I just press any key, then it quits. This is a bit of a problem.
All right. So what he has going on, essentially, he's saying that if I press any key, the program's gonna quit. Yeah, that's a problem.
What am I doing wrong? Let me just go and look back
So,
at my code here.
um,
I'm just gonna have a look at maybe.
yeah,
Maybe.
that's the cool thing about this program. We can like minimize
No, I don't want it.
indentions. We can minimize them to not show, which saves up a lot of room.
Hopefully it's not a problem. Let's just keep going. Let's just keep
Okay.
going. And does update need something in? Maybe it's something to do with update creating a problem.
Yeah, he's
There's my input.
got a lot of lines of code there. He's got like
Maybe-
200 lines
maybe
of code.
it's to do with Jeff. Maybe it's Jeff's fault. Global Jeff.
Okay.
Let's put another.
So under update, he adds, let's see, global Jeff, which I don't know what the point of this is. I'm not for sure. I'm not just watching his video to copy him. I want to learn from it as well.
Or maybe it's to do with Jeff. Maybe it's Jeff's fault. Global Jeff.
Okay.
Let's put another key. Oh, well done if you spotted my bug. I've said it if I've
Okay, so he has a bug. I don't think we need to put global Jeff here. I don't know why that would matter. I mean, it seems like it's working to me.
been too English about this and not programming. If key is Q or escape, I need to say or key is escape.
Okay. So the problem here is he said if Q equals escape or. So when you use or logic, it means that either one of these can be true. So essentially, if key is pressed, hold up, how do I say this? Define input key. If key equals Q, so if the Q key is pressed or the escape key is pressed, then we need to quit. Essentially, the double equal means it doesn't mean that key is equal to Q. It means that it's asking is key equal to Q. So we're asking if escape's equal to if key is equal to escape is what we're gonna want to also ask. So is key equal to Q or is key equal to escape? That's what we need to do. That's very Python oriented,
There we go.
so y'all may not understand. But
Now I think I did that after I
Right.
took away the.
he wants to
the button up
test.
here, so I don't know. Maybe it is still working invisible. Let's just. Okay, so now I'm tapping the screen. Pressing
Okay,
the buttons,
it
and
works.
It's not quitting. If I press escape.
What we're trying to test here.
Okay, lovely.
Can I
I'm glad
press
I did
Q?
that. So Jeff, you
Can
don't
I-
have to be
okay, yeah.
global, you're fine.
If I press Q, it should disappear, and that's what happens.
Right. For some reason, our program can find our entities as though they were global things.
All right.
Right. So now we need a first-person controller, and maybe somewhere. For
Cool. So we're getting to a very interesting part. We're gonna add a first-person controller to the mix, which will allow us to walk around. That's gonna be where it really gets interesting.
some controller to walk. So maybe instead of one cube, we'll have lots of cubes. So we don't want Jeff rotating.
Okay. So we're no longer gonna rotate Jeff, which I wouldn't mind saving this as a different file because I may want to know how to rotate something in the future. So I'm gonna save this as like with rotation to like remind myself. Okay, if I want to know how to rotate something, this is how you do it. Cool. All right. Then we're gonna open back our previous. We don't want to continue in that. All right.
And we want to go and create lots of them. So a grid of Jeffs, and we're going to do that with a loop. Now you'll notice that Jeff looks unhappy here.
So now we're gonna try to create 3 Jeffs, which is our block, which is named Jeff, which is pretty weird.
We need
But
somewhere for our first-person controller to walk. So maybe
Okay.
instead of one cube, we'll have lots of cubes. So we don't want Jeff rotating, and we want to go and create.
let's see, what's he gonna do?
Lots of them. So a grid of Jeffs, and we're going to do that with a loop. Now you'll notice that Jeff looks unhappy here, and if we try to run, it won't run. And that's because in Python, if you've just declared or defined your function, then
See
so
what's it
maybe
saying.
instead of one cube, we'll have lots of cubes. So we don't want Jeff rotating, and we want to go and create
Alright.
lots of them. So a grid of Jeffs, and we're going to do that with a loop. Now you'll notice that Jeff
Alright.
looks unhappy here, and if we try to run, it won't run. That's because in Python, if you've just declared or defined your function, then it's expecting something to be on the next line. So you can't just leave it empty like that. You have the right to say pass. So if you don't want to put anything in there, pass. I don't think a comment.
Okay, that's a cool new Python fact that I didn't know. If you want to end a function but you don't want to do anything with it, you can just type in pass. I think is what he's saying. If you just want to like avoid this function.
Will work either. But if you use the pass keyword,
Okay.
now everything's happy. So you just basically got an empty function ready to go. I'm gonna leave that.
Yeah, the problem, if you define a function, you have to end it with either like a return statement or now I know you can end it with pass. If you don't end defining a function, then you're gonna have problems because the function has to end.
Right. So now we need the first person control.
Okay.
No, we don't. We need a ground, else we'll just be falling. So
All right,
let's.
we're gonna add the
we
ground
made a
now.
Jeff, so we need to make lots of Jeffs. So let's create a loop for I.
For I
Range.
and
We'll
range,
go for, terrain width, we'll call it.
terrain
So
width.
We'll make a variable here. Terrain width equals 10. Just go fairly small.
All right.
So actually, we're not just going to make a line of 10. We want to make 10 across the x-axis and then 10 down the z-axis. So actually, you want terrain width times terrain width. We're going to square that.
Okay, so he's essentially like, hey, we want an area of land. We don't want a line of land. Like we want a square of land, not just like a line, if that makes any sense. So we're going to do length times width formula and try to hopefully make a square. So let's see, terrain width. All right.
That number, so it's going to be 100 blocks, cubes.
Okay. Cool.
Okay, so first thing we need to do is create.
So we're doing a for
So
loop.
We'll just call it bud. Like
Bud.
buddy. It's just a little traditional thing I do for temporary entities. For some reason, I call them buds. So buddy equals a new entity, and I want its model to be a cube, just as before.
Model
what color
cube.
should we go for? We'll go for green. Color equals color green,
All right, he's gonna color it green.
and yeah, we'll have the same texture
Alright.
as we had with Jeff. And we'll leave Jeff there for now, or shall we not? Nope. Sorry, Jeff.
He
Time's
deleted
up.
Jeff.
Time's up. And
Alright,
what else do we
texture.
need to do?
We called it grass, I believe. All right, I think he, I believe that he took out Jeff now, so we're gonna take Jeff out. Okay.
We need to position them. So now that we've got this entity stored in bud, we can say bud's x position. So you can just do dot x, and then that will mean your entity's x position. The longer
Alright.
way to do it would be position underscore x.
Bud position X.
Position will be a vector 3. Anyway,
Hold
position x
Let's
equals.
see.
What we want to do is
Bud
I
X equals
divided
I
by,
divided by
the terrain,
terrain.
and that will give us our, as it were, rows. And then bud dot z equals I modulus terrain width,
Okay.
and that will give us our
I'm gonna try to understand this here in a second.
columns. Okay, you might be a little bit confused. Don't
I
worry.
am.
We could use, if you've done grids and things before, we could use a loop with inside of a loop. So we could nest loops. So we could do the outside loop for the X positions, and an inside loop for the Z positions. But if we just want to create things with one loop, we can just use divided by and then modulo to get our grid positions. We'll see that working in a moment, and we'll say bug.y equals 0.
Okay.
Okay, let's just go and see if that's now created our 100 cubes. Yes, we've got 100 cubes, but presumably we started at 0, 0, but it looks like we just got a line of them, and we don't know
Okay, so we should get a line of cubes. Let's see if that's true. It looks like we have an error. Let's see. Texture equals grass. Previously, we defined grass, so grass should work. Let's figure out what's up with that. We've got an error. Line 20 texture equals grass. Positional argument follows keyword argument. Let's see. I'm not quite sure what that means. Let's take out the color. We don't need that. But if we want to do the texture, oh, I bet it's like this. Let's see. Okay. All right, cool. And let's go ahead and add the color back because I think that is necessary. I believe we can do color green. I don't know. That doesn't look right to me. I don't believe we put color twice. Let's just put color.green. Okay. How does this work? Okay. We get a problem now. Let's try color green. Okay. Let's take a look at what he's got going on.
100 cubes.
Yeah, he's just got okay, so what I keep forgetting is color equals color.green. It's not color.color.green, it's color equals color.green. And when we run it, we do not have any cubes, so we did something wrong. Let's figure out what we did wrong.
Yes, we've got 100 cubes, but okay.
Okay, so we've defined terrain width to be 10 for I in range. So let's see, for I in range. I haven't learned about for loops just yet, so I'm a little confused with that. But for I in range, terrain width equals terrain width times terrain width. So 10 times 10 is 100. Bud equals entity. All right, we understand what an entity is. It's a model, and it's equal to a cube, which is the color green, which is the texture grass, which we have already assigned. Let's see. I'm not quite sure what all this is about, but let's give it another go. It seems like it doesn't want to render it. I don't know why.
Let's just go and see if that's now created our 100 cubes.
All right.
Yes, we've got 100 cubes, but presumably we started at 0. That's quite exciting. Let's now generate our first-person controller, which Asina basically has done for us. So from Asina prefabs, import
from your Asina dot prefabs import
from excuse me, just sneezed. From
prefabs,
Asina prefabs first-person controller import the first-person controller object. So let's go. Correct that. I want to import the first-person controller, like that. Lovely. Now we can go get our first-person controller. We'll create the terrain first, and before we ask the app to run, we'll say subject equals.
All right. Let's see. From your Asina prefabs, first-person controller import.
Import the first-person controller.
Okay.
Lovely. Now we can go get our first-person controller.
Oh wow, I did not mean to open print.
And before we ask the app to run, we'll say subject equals. I guess you could call this player if you wanted to, or your name, whatever you liked, equals first-person controller. Then. want to move us, subject equals subject x equals 5, and we'll do that as well for our z position. And if you want to set two variables to the same number, you could do it in one line like that, instead of doing it kind of like on 2 lines. And our y position, subject y equals, let's put a 12 in the air, and then because we've got the first person controller, gravity should be working already for us. So let's just see if that's working. Whoa. Okay, so I fell through the instead of doing it kind of.
Let's take away texture. I feel like having a texture is not good in this situation. Let's try it now. For some reason our cubes are not showing up. He's got his cube showing up, so I don't know what's up with that for us. See, his indentation is also different. Let's see. Let's see.
Like on 2 lines. That's 2 correct that. I want to import the first person.
I'm gonna go back to the Python default font because I think my spacing is weird. Let's see, that Python default font, Deja Vu Sans. Let's change this back because I feel like we are struggling based on the font being strange. Let's see, Deja Vu Sans. Okay. Let's try to. That does not look like the same. We don't want condensed, we want average. I don't know if we have that. Okay, looking for the right font, Hi! Welcome to the stream. We're currently working on the project, and let's see, I'm looking for the right font to use because I want to make sure that the code uses a font that doesn't have bigger letters than others, like as in all the letters are the same size, if that makes any sense. Let's see. Yeah, this is a process. We are trying to create some blocks in our world. Let's see. Alright. We need to, I don't know. I don't know if I have this font that we need. This font should work though. What I have. Let's see. Well, no, let me see. Deja Vu. Okay. This one right here should work. Yeah. Okay. This looks like a pretty good font. All right. Let's try it. So if we go back to our tutorial, we're watching a tutorial currently because we are not very good at creating Minecraft
now we can
in Python. So
we'll create the terrain first, and before we ask the app to run, we'll set.
Alright, we're gonna go back a little while because we need to redo this terrain.
And we're going to do that with a loop. Now you'll notice that GF looks unhappy here, and if we try to run, it won't run. That's because in Python, if you've just declared or defined your function, then it's expecting something to be on the next line. So you can't just leave it empty like that. You have to write, say, pass. So if you don't want to put anything in there, pass. I don't think.
Alright, yeah, this is our little tutorial video.
If you use the pass keyword, everything's happy. So you've just basically got an empty function ready to go. I'm going to leave that there. Right, so now we need the first person controller. No, we don't. We need a ground, else we'll just be falling. So we've made a GF, so we need to make lots of GFs. So let's create a loop for I in range, and we'll go for terrain width, we'll call it. So we'll make a variable here, terrain width equals 10. We'll just go fairly small. So actually, we're not just going to make a line of 10, we want to make 10 across the x-axis and then 10 down the z-axis. So actually we want terrain width times terrain width. We're going to square that number, so it's going to be 100 blocks of cubes.
Alright.
Okay.
Currently we
So
are
first thing we need to do
creating
is create
a stage for the player to play on, like be on.
that cube. So we'll just call it Bud, for like a little buddy. It's just a little traditional thing I do for temporary entities. For some reason I call them buds. So my little buddy equals a new entity. And
Alright.
I want its model to be a cube, just as before.
Model
What colour should we go
equals
for?
cube.
We'll go for green. Colour equals colour green.
color equals color green.
And yeah, we'll have the same texture as we had with GF. We'll leave GF there for now, or shall we not? No.
Texture
Sorry, Jeff.
equals
Time's
green.
up. Time's up. And what else do we need to do? We need to position them. So now that we've got this entity stored
Alright.
in Bud, we can say Bud's X position. So you can just do dot .x, and then that will mean your entity's X position. The
Okay.
longer way to do it would be position underscore X. I think that's correct. Position will be a vector 3. Anyway, position X equals, what we want to do is I
Alright.
divided by the terrain width, and that will give us our, as it were, rows. And then
Okay.
dot z equals I modulus terrain width, and that will give us our columns. Okay, you might be a little bit confused. Don't worry. We could use, if you've done grids and things before, we could use a loop within inside of a loop. So we could nest, but if we just get our cubes, so 0. But look, let's now generate, and we don't know the cubes, to our 100 cubes. Okay, let's just go and see if that's now created our 100 cubes. Yes, we've got 100 cubes, but presumably we started at 0, 0, but it looks like we've just got a line of them.
Alright, so to anybody watching this stream, we have officially just created a platform, which we can only see like a little bit of it right now, but we have 10 by 10 cubes. So we've got 100 cubes, as you can see in this little number right here, 100 entities. We're going to go ahead and close it.
We don't know if we've actually got a grid, so
let's see.
That's quite exciting. Let's
So,
now
we need to
our
add a
first
character. So
person.
I've already actually done this. Let's go ahead.
To run, we'll pick, we want to move us.
Okay.
Subject equals
Subject equals
X equals 5.
first
and we'll do that as
person
well
controller.
for our Z position. And if
Alright.
you want to set two variables to the same number, you could do it in one line like that,
Subject
instead of doing
dot
it kind of
X
like on 2 lines.
equals
And our Y position,
subject
subject
dot Z
Y
equals
up to 12
5.
in the air, and then because we've got a
Subject
first-person controller,
dot
gravity
Y
should be
equals
working
12.
already for us. So let's just see if that's working.
Alright, so what y'all just saw
Okay, so
was
I fell through the floor.
my
It
guy
looks like
falling
we
through the floor.
successfully created a grid, and what we've forgotten to do is give our cubes a collider. Now I could give each cube its own collider, but what we really want to do is combine them all together and just give that whole model one collider, so it's a lot
okay.
more efficient. You wouldn't notice the difference for a size of just 100, but if we had 10,000, like we'd have in an ordinary terrain using my system, then we'd definitely have to do it this way. So, this also sets us up for creating a terrain, I guess. So, we're going to call our terrain, we'll call it just call it terrain for now. So terrain equals new entity, and model we're going to set to none. That's how to. If you want things to be empty in terms of the properties of an entity and a CNET entity, then that's the syntax. And we don't want a collider yet either. And we do want to use the same texture at the end. Anyway, we'll worry about textures and things in a moment. So after we've created our terrain of 10 by 10 cubes,
All right.
we then want to ask the terrain to combine all of those cubes into one model. And you do that by just saying the entity's name dot combine. Now, how does it know which entities to combine? Well, it will combine all of its child entities. So you can make entities within the scene kind of attached to what we call a parent entity. And if you have done that, it will follow that entity around if you move it, or if you want to combine it, it will combine into its parent. So first we're going to make all of our buddies. Bud parent equals terrain. There we go. And now that will combine. You can also auto destroy to false or true. I think it's automatically on true. So once you've combined all of these cubes, all of these models into this single model, then it will automatically destroy the child entities. But maybe, like in my terrain, you want to reuse these to create another part of the terrain, another chunk if you like, then you'd want to set this to false. That will come into play later on. So let's just have that as true, which is the default, so I can just leave it like that. And then I might want to set the terrain's texture. Let's just see what happens now. Just save the file. And oh, the whole point of doing this was to give it a collider, wasn't it? So instead of having to set the individual colliders, we can just set one collider, which is much more efficient for the physics engine. Here, and we want to say use the mesh, and that's what we just created with this combine function. The mesh is created out of all of these cubes.